So after going through the basics of Linux and networking, we'll be going over system admin. Specifically, one of the things that we'll discuss within system admin is Linux boot processing. As I'm searching up Linux boot processing, one of the things that we'll be going through is BIOS, MRS, GRUB, kernel, init, and run levels. Or the process or several stages. Linux booting process that includes several stages from the moment the system is powered on until the user is presented with the login prompt. So I'll be discussing the stages of booting process. So one of the first stages of booting process is uh, with BIOS, basic input and output system execution, or the UEFI. So let's go over BIOS. Basic input. This is how it will look. As the Google says, in order to access BIOS on Windows, you must process. This is to access it. But in computer BIOS firmware used to provide runtime services, which is one of the ways how you could boot process, or UEFI. Uh, UEFI. So UEFI as here. It is a unified extensible firmware interface. It's set up specific written by UEFI form. So the both BIOS and UEFI, the system firmware initializes the hardware components and loads the bootloader. BIOS and UEFI firmware performs a power on self-test or the post-check for hardware errors. So that is one of the processes or stages of Linux boot. And after that, it gets into bootloader. So bootloader is responsible for loading the Linux kernel into the memory. The bootloader can be the GRUB, as we saw previously, or LILO or SYSLINUX, depending on the distribution. So another stage would be the kernel. So, or before we move towards the kernel, bootloader, as Google states, also spells at bootloader, called boot manager or bootstrap loader, computer program that is responsible for booting a computer. Simple as that. Afterward, the next stages would be the kernel. Kernel. So the Linux kernel is loaded into memory and starts executing. And the kernel initializes the hardware component and mounts the root file system and starts the init process. And the kernel is, as Google states, is a computer program at the core of computer operation, where it interacts between the application and the hardwares. Or as it says, control over everything within the system. Complete control. So after the kernel stage, there is an init stage within the booting process. Linux init. So the init process is the first user space process that is started by the kernel. The init process is responsible for starting system services and user login sessions. As executes run level programs. So as we're talking about BIOS or the UEFI or the bootloader, uh, uh, or the GRUB, the Grand Unified Bootloader executed within the kernel itself, uh, and the init. So once again, the init, I'm not sure if I mentioned it. The init process is the first user space process that is started by the kernel. The init process is responsible for starting system services and user login sessions. So after the init stage, it is run levels. So so the run level in the Linux system has several run levels, which are different operating modes of the system, which you can see. And each run level defines a set of services that are started or stopped when the system is booted. The default run level is typically run level 5, which starts with X Windows system and presents the user with a graphical login screen. And after that, it is the service. So the services is a system services that are started by init process based on the run level. The services can be managed using the system CTL command within the Linux systems or using the servers command on old systems. And finally, being able to prompt the login once the system has uh, log in prompt. So once the login is prompted, the system has finished booting. The user is presented with login prompt. The user can then log into system and start it. So all those, the BIOS, UEFI, bootloader, kernel, init, run level, services, and prompting of login is important for system admins as it allows them to troubleshoot both issues and optimize system performances.